We have a few miscellaneous type of equations that we're going to do that we're going to pick up right now. So anytime we have a polynomial, again, a polynomial is where the exponent on the x is going to be positive or 0, and it's going to be a whole number. It won't be fractional. So we're going to move everything to one side. If it's linear, then you just solve it. We've already done those. But if it's higher degree, meaning second degree or higher, largest exponent is 2 or larger, then move everything to one side, factor it, and solve it. And I like this hint, you're never going to divide both sides by x. The reason being, we don't know if x is 0, and we can't divide by 0, of course. So let's take part A here. The advice is to get everything to one side, so I'm going to subtract the x to the other side, then factor. So we have 2 answers. Just a little hint of things coming up. If it's second degree like that, you can have up to 2 answers. You won't always have 2 answers, but you can have up to 2 answers. So part B. And what I'm going to do is I'm going to add the 2x squared and the 3x to the other side. Getting it equal to 0. And for this one, I have 4 terms that don't combine at all. So what I'm going to try to do is factor by grouping. So what I've done is I've gathered the first 2 together and pulled out a common factor. The second 2 together, pulled out a common factor. And now I'm going to notice that they have an x plus 2 as a common factor. We're going to take the x plus, so equal to 0, x squared plus 3 equal to 0. Now, this one, no problem. We subtract the 2 to both sides. This one, we subtract 3, and I get x squared equals -3. That means x equals plus and minus √3i. Again, make sure that I is not under the radical when you put it into like a computer or something. That will get marked wrong. Part C is a little more involved. So I'm going to start way up here. So we have x cubed, and I'm going to go ahead and subtract the 8 to the other side. This is a difference of cubes for that. I can write that formula up top right now. So a cubed minus b cubed gives us a minus b. Cubed. A minus b, and then a squared plus ab plus b squared. And a in this case was x, b in this case was 2. X minus 2 equals 0, no problem. X equals 2, there's one of the answers. Now, I just mentioned whatever the degree is, whatever that exponent is, that's up to how many solutions you could have. And so this gives us x squared plus 2x plus 4 equals 0. And I'll notice I have a quadratic. This one does not factor. So I'll need to use a quadratic formula. A in this case is 1, B in this case is 2, C in this case is 4. Now you'll notice I have a negative under the radical here, and I'm going to simplify it. So -2 plus and minus 2I root 3 over 2. Factor a 2 out and reduce it. I get negative 1 plus and minus I root 3. All right, so now we have what are called quadratic-like or quadratic-type equations. What we mean by that is that this exponent is double the size of that exponent. Then we have this particular type way of doing things. So what we're going to do is I'm going to do this using a substitution. We can do this without a substitution, but I like using a substitution. So for part A, I'm going to let u equal x plus 6 because I see x plus 6 there and there. By the way, it's not wrong to FOIL that out, distribute the 3, combine your like terms. You'll still end up with the same answer. But this one becomes u squared plus 3u plus 2 equals 0. And that factors set them each equal to 0, and I get u equals negative 2 and u equals negative 1. However, I don't want to solve for u, so I'm going to replace u back with x plus 6. And I'm going to subtract the 6 to the other side. That x gives me negative 8. Subtract the 6, x gives me negative 7. So there are my two solutions. Again, there are ways of doing this without substitution, but I like using the substitution. Next up, I'm going to, this is part B, I'm going to let u equal x to the 1/3. This gives me u squared plus 7u plus 10 equals 0. We can factor this one. U plus 2 equals 0, which means u equals negative 2. U plus 5 equals 0. U equals negative 5. And once again, u is x cubed, or x to the 1/3, pardon me. And the only way to get rid of that 1/3 is to raise both sides to the 3rd power. Negative 8, x equals negative 125. So we have two solutions. Part C, we have 1 over x plus 6 squared equals 1 over x plus 6 plus 12, and I'm going to let u equal x plus 6. So I get 1 over u squared equals 1 over u plus 12. And I'm going to multiply through an LCD, which in this case is u squared. One equals u plus 12u squared. Now I have a quadratic. I'm going to subtract the 1 to the other side, so I get 12u squared plus u minus 1 equals 0. This one is going to factor yes, equals 0. U is x plus 6. Subtracting the 6 to the other side, because I'm low on room, you'll have to get the common denominator and everything. But this gets us x equals negative 19 over 3, comma, negative 23 over 4. And I'm going to leave part D for you to try to wrestle. See if you can piece that one together. A hint on what to let u be. If it's in this form here, it's always going to be whatever that is. So in this case, x plus 6 is that. X plus 6. In this case, x to the 1/3 is that. In this case, this doesn't really match because it doesn't follow that particular pattern, although eventually it does. Yep, that's how that works. So moving on to the next page. All right, part 3, extraneous solutions and radical equations. An extraneous solution is an answer that is not a solution to the original equation. This pops up sometimes when we do things to solve these equations, we've actually added something to the problem that wasn't originally there. And so we have to be careful with that. So with radical equations and rational equations, those are the ones with the crazy fractions like we just did a second ago, rational equations, then sometimes we end up with an answer that really isn't an answer. So we have to be really careful. And radicals I just mentioned, this is the other one that I just mentioned, the 1 over x plus 6 and so on, and absolute value equations, we have to be careful. With radical equations, we have to isolate a radical. Sometimes there may be more than one, as in part C. Square both sides or raise it to the appropriate power. So if it's square root, then we will be squaring both sides. If it's cube root, then we'll be raising both sides to the 3rd power. If it's 4th root, then 4th power, and so on. And when we're done, we got to go back and make sure that we don't end up with an extra answer. So since I need this space for part C for sure, let's start with A. So I'm going to add the 3 to the other side. Divide by 4. And now I'm going to square both sides. So we'll raise both sides. 2nd power. And now we have to check that. 9 over 16. Square root of 9 over 16 is 3 over 4. 4 divided by 4 is 3 equals 3. We're good. So this is a valid solution. Part B. Here we have cube root of 2x plus 1 equals 5. Now, because it's cube root, instead of raising to the 2nd power, we're going to raise it to the 3rd power. And solve the equation. 5 to the 3rd power is 125. Minus 1. 124. Divide by 2. 2. 62. All right, let's try this out. 2 times 62 is 124. 120 plus 1 is 125. Cube root of 125 is 5. We're good. All right. Part C is long. Let's see how far I can start this one. C. All right. Well, the first thing it says is to isolate a variable or a radical. So I'm going to go ahead and add that to the other side. And even though there's a 2 there, I'm going to go ahead and square both sides now. Now, this gets a little crazy. If you can recall this formula, that is going to apply to this here, this side. A in this case is the radical 2x plus 3. B in this case is the 1. So here we go. So I'll put this here. So square root of 2x plus 3 squared, that's the a squared, plus 2 times the radical 2x plus 3 times b, which is 1 in this case, plus 1 squared. A squared plus 2 times a times b plus b squared. Right there. It's all equal to this here. So this is 4x plus 1. So here I'll distribute 4x plus 4. Here, the radical goes away. 2x plus 3. 2 times 1 is just 2. So plus 2 radical 2x plus 3. 1 squared is 1. I'm going to go ahead and combine it by like terms. Three plus 1 is 4. We got a lot going on with this one. I still need to get this radical by itself over here. So I'm going to move this to the other side. Here, the 4s are gone. Yeah. And here, this is now 2x. 2x equals 2 radical 2x plus 3. And I can divide a 2 out. X equals radical 2x plus 3. Now, I'm going to square both sides again. And I'm going to move everything over to get it equal to 0. This factors x minus 3, x plus 1. This means x equals 3 or x equals -1. Now, I have two answers. I need to check them both. It's possible both work. It's possible only one of them works. It's possible none of them work. So I'm going to have to scooch this up, and I'm going to actually work this out. So at x equals 3, let's see what we get. I'm going to plug it into here. So this is 2 times root 3 plus 1 minus radical 2 times 3 plus 3 equals 1. 2 times root 4 minus root, that's 6 plus 3, that's 9. 2 times 2 minus 3 should equal 1. 4 minus 3 should equal 1. 1 equals 1. Yay, it works. I gotta check it. We also have to check x equals -1. So we have 2 radical -1 plus 1 minus square root 2 times -1 plus 3 should equal 1. This gives me 2 root 0 minus the square root. That is -2 plus 3 is 1. This equals 1. That goes to 0. So root 1 is 1. So this is -1 equals 1. Nope. So x does not equal -1. So my final answer is only x equals 3, because these two didn't equal one another. that's a long problem. That one takes time. You may need to break that down and watch the video a few times to really see what was happening with that. Hope that helped.